Hello and welcome to another episode of the Scripting and Podcast. I'm Fernando as usual, and I have a more of a technical episode today. I want to cover 3 mistakes that you're most likely making if you're new to unit testing, and I think they're very relevant to fix, that they should be fixed as soon as possible to make your unit tests more relevant and more useful in the long run. So there are essentially 3 main ones that I want to cover. So the first one I want to start with is one that, again, if you're new to testing, if you're new to unit testing, then it might be easy to fall for, is testing more than one thing at a time. So you have to remember that if you're doing unit test, which should be at the basic of every development process, if you're working on a big application, your unit test should only focus on one thing only. Even if you have a single function to test or a single method, that method might have different outcomes. It might have different behaviors based on the input data that you pass. Maybe it fails when you don't pass the right parameters. It gives you an error if you pass some invalid data. You can't be testing all of those conditions within the same unit test. And why is that? You can. You shouldn't. That's the expression I should have used. You shouldn't be testing all those conditions within the same unit test, even if you're testing the same piece of code. Okay? Why is that? Because the test will work either way, but when it fails, and here is the key, because one of the major benefits of having unit tests is to have them fail, because they will show you problems with your logic, with your code, whenever you make changes. When this test fails, if you're testing 3, 4, 5 different conditions for the same method, for the same piece of code, then you won't really know exactly what failed. You'll know that there is a problem with that specific piece of the code, but you won't really know exactly what's wrong with it. And you want your unit tests, errors to be as useful as possible. So whenever one of them fails, you know exactly what failed, what condition, what path failed within your logic. But if you have 4 or 5 different tests within the same unit test, then you don't really know exactly what went wrong. You just know that there is a problem, which is still useful, don't get me wrong. This is not a either do it this way or it won't work. It will work, you'll get feedback, but it's not ideal. If you want to improve the way you write your unit tests, just remember that test one single condition per test. This will also make sure that your test cases are easier to maintain and easier to read, if that's something that someone needs to do to understand the code or how the method works or whatever. So that's also something that can happen, and the less code it's inside each of these test cases, then it's going to be easier to deal with. So they keep that in mind as well. So the second problem that I see with unit tests in particular is relying on external services, and this is one that I've had a conversation with many developers in the past, and some developers like to do it this way specifically for convenience. I personally don't think it's useful, and I personally don't think it's a unit test if you do it this way. But what do I mean by external services? Anything that's outside of the code that you're testing, right? So let's say that you're testing code that interacts with the database. A lot of developers like to create a test database that is created during test ramp up and then destroyed during test ramp down. During the closing of the tests, they add a condition to a piece of code to close and delete that database. So they can test that the data is saved, and then they run other tests to query that data and make sure that it's properly returned and so on. So what's my problem with that? The logic that you wrote is using a database driver. And by using the external database that you create and destroy, you're also testing the database driver. If you want to test if the data is properly saved, you don't really have to save it on a database. You just have to make sure that you're calling the right method, which you can absolutely do with techniques like Spice and others. You can record what kind of methods get called and with what parameters, so you know how your code is using or interacting with that piece of code, with the driver of the database. But if you go that extra step and add in the database, even if it's a test or a database, you're implicitly testing something that has already been tested. Your database driver, whatever library you're using, it's probably being tested by the team that created it. So you don't really have to worry about that. You're just adding extra steps to the tests that are not really needed. Especially so if you're testing a database that is with a database, for example, or with an external API, or with any other, even the hard drive. Maybe you're testing. Maybe your code is reading a file from the hard drive. If for any reason the hard drive of the machine where the unit test is running fails, your test is going to fail. But it's not going to fail because you wrote bad code or because there is a problem with your logic or anything. It's going to fail because of an external reason. And that makes no sense for the unit test. The unit test should be only looking after your own code. There are other type of tests, like integration tests, that definitely will care for making sure that all pieces of code work together with other external services and so on. But if you're writing unit tests, then you have to care about your own logic, and that's it. So that's essentially, my problem with using external services. Any type of external entity, a database, your hard drive, an external API or an internal API, anything, even a service within your architecture. If you have to call something that it's outside of the realm of the piece of code that you're testing, you have to mock it. You have to provide an alternative that is controlled by you. Why? Because that way you can force the results from the with this alternative. You can say that you're testing the database interaction, right? But you don't really care about the database. You want to make sure that your own code works well when the database responds properly and when there is no database access or when the database returns no results. For example, those three cases. How will you control what you get out of the database if you're not in full control over the database? So the way you do it is you provide a mock of the database interface, essentially. That might be, if you have your driver, you might want to mock the driver and those specific methods that you call. So you through something called dependency injection, which is a technique where you can inject external dependencies into your code. You can overwrite the default dependencies, essentially, the default driver for the database, and use your own. During the testing, inside the testing environment, you will be using your own driver that responds exactly what you want for specific tests. So when you have a test that wants to make sure that your logic responds well to an error reading from the database, then you will return an error or you'll throw an exception or whatever. And whenever you want to see if your logic responds well when there is a valid response from the database, you'll write code that returns a valid response as if it was querying the actual database. But it's not. So that way your test will run faster because everything is encoded in memory and there's nothing really using an external service. Your test will only fail if there is a problem with your logic, which is what you want. And that's it. You'll have more control over exactly what's happening with your tests and how to write them. That's also the huge benefit I see on this. And the last item I wanted to cover is aiming for coverage, for code coverage. A lot of teams tend to focus on, an arbitrary percentage of coverage, trying to stay away from 100% coverage on their tests, because that might be like too much. So they're aimed for something between 80 to 85, 90% of code coverage. And when they reach that point, they'll just call it done and say, well, we have the minimum quality standard in our tests to make sure that whatever we're deploying is stable enough if there are no errors in our tests. And that might be true. That might be true for your particular case, but in general, if you're just aiming for coverage without really caring about anything else, you might be missing some key metrics. You might be missing some key logic path that you ignored just because you were already at the sweet spot when it came to coverage. What you really have to worry about, instead of an arbitrary number for the coverage, is more about making sure that you're covering the critical and most common logic path within your code. You can use code analyzers that usually come with testing suites to validate if you're covering all logic paths. Review those and make sure that the ones that you're leaving out are really not that relevant or not that big of a problem because they're simple enough. But you have to look closer at the code instead of just looking at a number and saying, I'm done. Because if you look at the coverage, and you might have like a lot of else clauses that are very simple in logic, but have a lot about, require a lot of code lines, that might increase your coverage when in reality you're avoiding the actual, logic path that require less lines of code, but contain the core logic of your business. I don't know if that makes sense, but what I'm trying to say here is that just by looking at an arbitrary coverage might accidentally make you leave out potentially critical path without testing. So make sure that you look at what actually gets tested through code analysis and adjust your tests according to that and not just according to an arbitrary number. Mind you, also pay attention to coverage. It might be a good first indicator if you're doing it right, or if you're just missing a lot of your code. Maybe you have like a 50% coverage and you thought you were doing great, then definitely you have a lot more to cover. But just don't only pay attention to that number, pay attention to the rest of the analysis as well. And that's it. This is a short episode today. If you're new to unit testing, or if you've been doing it for a while, but you haven't really been paying a lot of attention to the quote-unquote theory behind unit testing, I recommend that you read up on it because it's a really interesting space. It's definitely not a boring task. It's definitely not something that only junior developers should take as tasks. It's definitely very useful if it's done right. So you want to get unit testing right from the get-go. So from this episode, I hope you remember these 3 tips. Just make sure that you're testing not more than one thing per test. Make sure that you're not relying on any external services when you're coding, when you're writing the code for your test. And you remember that just aiming for coverage, for code coverage, is not enough. That you have to look into the details of what you're testing to make sure that you fully tested your application. And that's it. That's it for this episode. I hope, as usual, that you found it interesting, and I'll catch you on the next one. See you around. And that was it for this episode. Thank you so much for listening. And don't forget to rate the podcast in your favorite podcasting app so that it can reach more developers. In the meantime, if you'd like to follow me on Twitter, or X as people call it, just look for me at DeleteMan123. And that's it. Thank you, and catch you on the next one.